Okay, just recently I did a few interesting videos. We did this a week or so back. We did this integral up here, and then there was some discussion about the different forms of the answer. And then in the previous video, I went over this formula here. Well, I used this as a tool to kind of compare different values of arctan. So I'll leave this business behind. We won't talk about the specifics of that, but I wanted to extend that. So if anyone that watched those other videos, I'll provide a link to the other videos, but also I find this is another useful tool you can use for comparing different values of your integral when they're not exactly the same. And so what we'll do is we'll just go over how this works. We'll show that this is true, and then you can maybe use that to extend what we did in the other video. Okay, so to start with, we're going to need this tool we have up here for the inverse hyperbolic tangent and relating it to natural log. And so before we do anything, we want to show where did this come from. This comes out pretty easily if you just do the integral of dx over 1 minus x squared. Because essentially with the constant, both of these are answers to this integral over here. So we could basically show it with an integral. So that'd be a quick way to show that these are true, but I think it might be more satisfying to prove it directly. So what I'll do is we'll set this, I'll just create another variable. We'll set this equal to y. Okay, and we'll focus on the left side. We'll focus on this going left to right here. Then just using the property of the inverse, we can say from this that x equals arctan y. And then real quickly, tan y is the same thing as sin y over cos y. But each of these, but the definition of sin is going to be ey minus e to the negative y over 2. And then cos is going to be really similar with a plus sign over 2. Our 2's are going to cancel. And then we just have this thing over this thing. So let's just clean this up a little bit. Then from here, all I want to do is I'm just going to multiply this by 1, but we'll do it as multiplying ey over ey. And we'll distribute this in here. So it's going to give us, when we multiply that in, we're going to have e to the 2y minus 1, and then we're going to have e to the 2y plus 1. Then just to simplify this a little further, what I'm going to do is going to rewrite this. I want to kind of combine terms. So I'm going to write this as e2y plus 1 minus 2. And then here you'll notice with this piece, this will be 1. I'm going to separate it into two terms. Okay? And so that way we have 1 minus 2 e2y plus 1. Now let's bring our x back into play. I'll subtract the 1 from both sides. So we're going to have x minus 1 over here. Then I'm just going to use this minus sign to reverse the sign over here. We can take the reciprocal on both sides. So we're going to have e2y plus 1 over 2 equals 1 over 1 minus x. I can multiply a 2 on both sides. Okay, so we have a 2 on top over here. I'll subtract off the 1. Now this 1, we can get a common denominator, and we can write this as 1 minus x over 1 minus x. So then what do we have left? We're going to have here 2 minus 1 is 1. And then we're going to have, distributing in this minus sign, well, 1 plus x. 1 minus x equals just e to the 2y. I'll take a square root on both sides. That's going to give us here, that's going to isolate our ey. Because what I want to do is I want to solve back for y. So we're going to have, we've isolated e to the y. We'll have, this is actually going to be plus or minus 1 plus x, 1 minus x. But I can get rid of these signs because we know that e to the y is always positive. So we'll just remove this here. We'll take a natural log on both sides to isolate the y. And we're left with y equals this thing right here. But this square root is like a half on the exponent, so we can write this in the same form we have up here, which is half natural log 1 plus x, 1 minus x. This matches this, so we've shown this formula here. So now let's put it to use and see if we can get back to our goal. So now that we've shown this formula, I think we've really done the hard work. So we can really do we'll go in this direction. For this, we want to show that this is equal to arctan. What we can do is rewrite this using this formula. So we're going to have minus I. Using this, we're going to have half natural log. The input is no longer x, it's ix, so we just have to change that input. So we're going to have 1 plus ix, 1 minus ix. Well, at this point, we can bring back the formula I showed at the beginning of the video, this thing right here. So if we can get, you notice we're getting it towards this, if we can get it to exactly like that, then we have our arctan. And it's getting pretty close. So we're going to have, let's just rewrite this as half I to make it just like that. So if I put the minus in the exponent here, then we can just take the reciprocal, and we're going to have natural log 1 minus ix over 1 plus ix. So this comes together really quick because we have an exact match. So this thing is actually just arctan. So again, I'll give a link to these other two videos. I also want to give a link to my trig cheat sheet on my website. I think on there you'll find a lot of interesting formulas that are pretty useful like this, like the complex definitions. And there's also some derivations on there. I don't know, there's a lot of good things. I'll give you a link and you can check it out. Okay, I'm too tired to talk at this point, so I just wrote it. Thanks everyone, have a good day.